In the present video, we will discuss the gate previous questions of inventory management. Before that, we will discuss the important formulas. First one is the purchase cost, which is equal to the price per unit into demand per unit time. So where C equal to the purchase cost of an item and D equal to the annual requirement of an item. So purchase cost equal to the C into D. Second one is the carrying or holding cost. First formula for the carrying cost is the carrying cost equal to the CH into I max plus I minimum divided by 2, where CH equal to the cost of carrying 1 unit of an item in the inventory for a given length of time, and I max equal to the maximum inventory. So generally maximum inventory value equal to the Q, and minimum inventory is the I minimum, which is equal to the 0. Then carrying cost, where CC equal to the CH into Q by 2. And second formula is the carrying cost equal to the R into C, where R is the carrying charges as a percentage of average rupee value on an annual basis, and C is the unit cost of the item in rupees. Next one is the ordering or setup cost. Ordering cost equal to the cost per order or per setup into cost of orders or cost of setups placed in the given period. So ordering cost equal to the C0 into D by Q, where C0 equal to the ordering or setup cost per order, D equal to annual requirement, Q equal to the order quantity per order. Next one is the shortage cost. Shortage cost equal to the cost of being short 1 unit of an item into average number of units short, and average number of units of short equal to the minimum shortage plus maximum shortage divided by 2 into period of shortage. This is the schematic representation of inventory control models. Most of the competitive exams asking the questions in the deterministic demand model only. So in the present video also we will discuss the gate previous questions on the deterministic demand. This is the brief classification of deterministic inventory control models. First we will discuss the model 1A, EOQ model with constant rate of demand model. Order quantity replenished in one inventory cycle equal to the consumption of stock in one inventory cycle, which is Q equal to the D into T, where small t is the cycle time. And next for the total variable inventory cost, TVC equal to the annual carrying cost plus annual ordering cost. Annual carrying cost equal to the average inventory level into carrying cost per unit per year. Annual ordering cost equal to number of orders placed per year into ordering cost per order. So TVC equal to the I max plus I minimum divided by 2 into CH, which is equal to the annual carrying cost plus number of orders D by Q into ordering cost C0. Then TVC equal to the Q by 2 into CH plus D by Q into C0. This is the schematic representation of the inventory cost and the order size, and Q star is the economic order quantity. At the Q star, carrying cost equal to the ordering cost, then Q by 2 into CH equal to the D by Q into C0, then economic order quantity Q star equal to the root of 2D C0 by CH. And we have to remember the other important formulas. Optimal intervals between the successive orders, T star equal to the Q star divided by D. We have to remember this formula. And the second one is the optimal number of orders, N star equal to the annual demand divided by optimal order quantity. So N star equal to the D by Q star. So remember another formula. And one more important formula, optimal total variable inventory cost TVC star equal to the D by Q star into C naught plus Q star by 2 into CH, which is equal to the optimal total variable inventory cost equal to the TVC star equal to the root of 2D C naught by CH. You have to remember another formula. And last one is the optimal total inventory cost. So in the total inventory cost, we have to include the purchase cost, which is the fixed one. So fixed cost, that is the purchase cost plus total variable inventory cost. One more important formula, reorder level ROL equal to the LT into small d, where LT equal to the lead time and small d equal to the daily consumption rate. And we can be determine the ROL value by using the similar triangles. That is the Q star by ROL equal to the T star by LT. Let's discuss the another model, model 1B, EOQ model with different rates of demand model. So here annual carrying cost equal to the Q by 2 into CHT1 plus CHT2 plus up to the CHTN. Then Q by 2 equal to the CH into capital T, where capital T equal to the T1 plus T2 plus up to the Tn. And one more important formula I have to remember. So in the model 1B, Q star small q star economic order quantity equal to the root of 2D C naught by T into CH. Next model is the model 1C, economic production quantity model when supply is gradual. Here P is the rate of production and D is the rate of demand, and here P is the greater than the D, and TP is the time period required to receive one entire batch amount Q at a rate P. Then the rate at which the stocks are arrived is small p equal to the Q by TP and TP equal to the Q by P. So here TP is the time required to receive complete one entire batch of amount Q, and this is the we are calling as the maximum inventory, Imax. So this Imax equal to the TP into P minus D. And one more important formula. So Imax equal to the TP into P minus D. And in this model, Q star economic order quantity Q star equal to the root of 2D C naught by CH into P divided by P minus D. And these are the another important formulas. So TVC star equal to the root of 2D C naught CH into 1 minus D by P. And TP star, optimal length of each lot size production run, which is equal to the Q star by P. And optimal production cycle time, T equal to the Q star by D. Number of production cycles N star equal to the D by Q star. Next model is the model 2A, EOQ model with constant demand and variable order cycle time. First formula T1, where the T1 is the when positive inventory level is available. So this positive inventory level we are considering the capital M. Then T1 equal to the M by D. And cycle time small t, which is equal to the Q by D. And one more formula is the T2. So time T2 is the shortage occurs, T2 equal to the Q minus M divided by D, and ordering cost equal to the number of orders D by Q into C naught, ordering cost D by Q into C naught, and carrying cost equal to the M square divided by 2Q into CH, and shortage cost equal to the 1 by 2Q into Q minus M whole square into CS. And other formulas in this model, Q star equal to the economic order quantity root of 2D C naught by CH into CH plus CS divided by CS. And optimal stock level, M star equal to the root of 2D C naught by CH into CS divided by CH plus CS. And next one, so optimal inventory cost, variable inventory cost TVC star equal to the root of 2D C naught CH into CS divided by CH plus CS. And a few more formulas. Optimal shortage level R star equal to the Q star minus M star, and total cycle time T equal to the Q star divided by capital D. Next model is the model 2B, EOQ model with constant demand and fixed reorder cycle time. So TVC equal to the carrying cost plus shortage cost, and carrying cost equal to the M square divided by 2Q into CH, and shortage cost equal to the 1 by 2Q into Q minus M whole square into CS. Then TVC equal to the M square divided by 2 into Q into CH plus Q minus M whole square divided by 2 into Q CS, and M star equal to the CS divided by CH plus CS into D into T. And next one is the model 2C. EOQ model with gradual supply and shortage is allowed. So in this model, optimal manufacturing quantity Q star equal to the root of 2D C naught by CH into P divided by P minus D into CH plus CS divided by CS. And next formula, number of shortage Q2 star, which is equal to the Q star into 1 minus D by P into CH divided by CH plus CS, and manufacturing time T1, which is equal to the Q star by P, and production cycle time small t equal to the Q star divided by small d, which is equal to the capital D also. And this is the summary of the all the 6 models. And next models are the model 3A and 3B, model with 1 price break and model with 2 price break. So for these models, procedure is the same. Always have to start with the lowest price. Then you have to calculate the EOQ and check whether EOQ falls in the quantity range. If not, move to the next price level. And when a feasible EOQ is obtained, compare its total cost with next discount to break quantity. Then I have to choose the quantity with the lowest total cost. Okay, let's see the gate previous questions. Let's see the first question. The inventory holding cost of an item is 0.5 rupees per unit per month, and the ordering cost per order is 550 rupees. A stockist needs to supply 10,000 units of the item per year to the customers. Assume demand is fixed and shortage cost is infinite. Using classical economic order quantity model, the optimal lot size is dash units per order. So first I have to write down the given data. So here it is given the holding cost of an item is 0.5 rupees per unit per month. So it is given the per month. So then CH equal to the 0.5 rupees per unit per month. And next ordering cost is given the 550 rupees per order. So C0 equal to the 550 per order. And supply 10,000 units of the item per year. So here it is given the year wise. Then holding cost also have to convert to the year wise. So which is the 0.5 into 12, that is the 6 rupees per unit per year. So this model is the EOQ model with constant rate of demand, because there is not given the any production rate and demand rate, and also not given the shortage cost. So this model is belongs to the first model, model 1A, EOQ model with constant rate of demand. So have to calculate the EOQ value. So we know the formula EOQ equal to the root of 2D C0 by CH. So here D is given, annual requirement, that is the 10,000 units, and C0 also given, CH also given. Substitute all the values, then EOQ equal to the root of 2 into 10,000 into 550 divided by 6, which is equal to the root of, so 18,33,333, which is equal to the 1354 units. Let's see the next question. A company uses 3000 units of a part annually. The units are priced as given in the table below. It cost 150 rupees, place an order. Carrying cost are 40% of the purchase price per unit on annual basis. The minimum total annual cost is dash. So let's see the solution. First write down the given data. So here given the company uses 3000 units of a part annually. So annual demand capital D equal to the 3000. And in the table given the unit price for the different quantity. For the quantity 1 to 499, it is the 9 rupees. And quantity 500 to 999, unit price is the 8.5 rupees. And quantity 1000 or more, its unit cost is the 8 rupees. And here observe, there are the two price breaks. One is at the 500 quantity, another one is at the 1000 quantity. So let's consider B1 equal to the 500, B2 equal to the 1000. And next it is given the, so cost 150 rupees to place an order. So ordering cost C0 equal to the 150. And carrying cost are 40% of the purchase price per unit on annual basis. So small r equal to the 0.4. Then we have to determine the minimum total annual cost. We know that when the total cost equal to the purchasing cost plus ordering cost plus carrying cost. So first we have to go for the step 1. Consider the lowest price and determine the EOQ or the required price. We know the EOQ value equal to the root of 2D C0 by CH. So lowest price is the 8 rupees. Then Q star equal to the 530.33. So at this price we have to check the quantity. So it is required the, so 1000 or more, but we got the only 530 units. So it is the not feasible. Then I have to go for the next step. So next step is calculate the Q2 star based on price C2. Here price C2 is the 8.5 rupees. Then Q2 star will become the, so 514.49 units. So here I have to check the, this quantity is feasible or not. So at the 8.5 rupees required quantity is the 500 to 999. We got the quantity is 514.49, which is the in between the 500 to 999. So which is the feasible. So at this unit cost for the required quantity, we have to check the total cost. So then we have to determine the total cost at the EOQ units, as well as we have to calculate the total cost of the B2 quantity. Then, okay, next we have to calculate the total cost or the Q2 star quantity. So Q2 star quantity is 514.49, which is the lies between 500 to 999, and the unit price is the 8.5. So then total cost equal to the 27,249.28. Similarly, we have to calculate the total cost at the B2 quantity. Here B2 quantity is 1000 or more and unit price is the 8 rupees. Then total cost at the 1000 quantity, it is the 26,050. So among these two total cost, so minimum total cost is we are getting for the 1000 quantity only. Then we have to go for the optimal quantity level is the, so 1000, and minimum total cost is the 26,050. Let's see the next question. A company orders gears in conditions identical to those considered in the economic order quantity model in inventory control. The annual demand is 8,000 gears. So here it is given the annual demand. Let's consider the capital D equal to the 8,000. Cost per order is 300 rupees. So ordering cost C0 equal to the 300 per order, and holding cost is 12 rupees per month per gear. So here holding cost is given the 12 rupees per month per gear, but we need the holding cost per year. Then 12 rupees into 12 months. So 12 into 12, 144 rupees per year. So CH equal to the 144. And given the company uses an order size that is 25% more than the optimal order quantity determined by the EOQ. So company size, let's consider Q equal to the 1.25, which means 25% more than, then 1.25 into EOQ. So Q equal to the 1.25 Q star. So next, the percentage change in the total cost of ordering and holding inventory from that associated with the optimal order quantity is. So have to determine the percentage change in the, but here mention the total cost, but it is the total variable cost, because we have to considering the ordering cost and holding or carrying cost only. We are not considering the fixed cost. So have to determine the, so percentage change in the total variable cost for the company size Q with respect to the EOQ size. So let's see the solution. So first we have to determine the EOQ. So this model is belongs to the model 1A, EOQ model with a constant rate of demand. And EOQ or Q star equal to the root of 2D C0 by CH. We know the all the values, then substitute. Q star equal to the 182.57. This is the EOQ value. But company uses Q equal to the 1.25 Q star. Then Q equal to the 1.25 into 182.57, which is equal to the 228.2. Next we have to determine the total variable cost at the Q quantity as well as Q star quantity. First I have to determine the total variable cost at the Q star quantity. So I have to use the any formula. So which is the carrying cost plus annual carrying cost plus annual ordering costs. Otherwise I have to use the directly used formula. TVC star equal to the root of 2D C0 CH. Better have to always use this formula. So then, so total variable cost at the Q star quantity is the 26,290.64. Then we determine the total variable cost at the Q quantity. So here total variable cost will become the 26,947.5. Next we determine the percentage change of the total variable cost, which is equal to the 26,947.5 minus 26,290.64 divided by 26,290.64, which is equal to the 0.025. So into 100, then this value is the 2.5. So option A is the correct answer. Let's see the next question. With reference to the economic order quantity model, which one of the options given is correct? So here it is given the graph for the cost per unit and the order quantity, and here curve P4 represents the purchasing or production cost, and curve P3 is for the ordering cost or the setup cost, and curve P2 is for the carrying cost or holding cost, and curve P1 is the total cost. So let's observe the options. Option A is, so P1 is the total cost, okay, and curve P2 is holding cost, okay, curve P3 is for the setup cost, okay, and curve P4 is for the production cost. So option A is the correct answer. So let's see the next question. Which one of the following is not a form of inventory? Option A, raw materials. Option B, work in progress material. Option C, finished goods. Option D, CNC milling machines. So we know that inventory refers to items that a company holds for sales or Uses in the production process. So the main types of inventory are the raw materials, work in progress materials, and the finished goods. So among the given options, so raw materials, work in progress material, and finished goods are the inventory types, and CNC machines are the not a inventory type, because CNC machines are not inventory, they are fixed assets used to produce goods rather than goods held for sale or consumption in production. So CNC milling machines are not coming category of the inventory. So option D is the correct answer. Next question is, the demand of a certain part is 1000 parts per year and its cost is 1000 per part. So here given the annual demand, capital D equal to the 1000 parts per year, and also given the cost per part, capital C equal to the 1000 per part. The orders are placed based on the economic order quantity EOQ. The cost of ordering is 100 rupees per order and the lead time for receiving the orders is 5 days. So here I mention the ordering cost C0 equal to the 100 rupees per order, and also given the lead time which is equal to the 5 days. If the holding cost is 20 rupees per part per year, so holding cost or carrying cost is given CH equal to the 20 rupees per part per year, then inventory level for placing the order is dash parts. So have to determine the ROL, reorder level, we have to determine, and we know the relation of the ROL equal to the lead time into daily consumption rate. Daily consumption rate which is equal to the, here it is given the annual demand divided by 365 days. Then small d, daily consumption rate equal to the 2.73. Then reorder level equal to the lead time into daily consumption rate which is equal to the 5 into 2.73. Answer is the 13.69, but you have to round off the near integer, then 14 parts. So 14 is the answer. This problem we can be solved in the another way also. So this is the reorder level. So here observe, here it is the one triangle and this is the another triangle. So both are the similar triangles. So from this one we can be written as Q star by ROL equal to the T star by lead time. Q star equal to the root of 2D C0 by CH, which is equal to the 100 parts, and T star equal to the Q star divided by D, which is equal to the 1 by 10 year, which is equal to the 36 days. Then so Q star 100 divided by ROL equal to the T star 36 divided by lead time equal to the 5. Then ROL equal to the 14 parts. Next question is, annual demand of a product is 50,000 units and the ordering cost is the 7,000 per order. So it is given the capital D 50,000 and the C0 equal to the 7,000. Considering the basic economic order quantity model, the economic order quantity is 10,000 units. So EOQ or Q star also given, which is equal to the 10,000. When the annual inventory cost is minimized, the annual inventory holding cost. So how to determine the annual inventory holding cost? We have to determine. So which is equal to the CH into 1 by 2 into EOQ. So we know that formula is equal to the EOQ equal to the root of 2D C0 by CH. So here D is given, C0 is given, and the EOQ also given. Then CH equal to the 7 rupees. And annual inventory holding cost equal to the CH 7 into 1 by 2 into EOQ equal to the 10,000. That is the 35,000. So answer is the 35,000. Let's see the next question. An item can be purchased for 100 rupees. The ordering cost is 200 and the inventory carrying cost is 10% of the item cost per annum. If the annual demand is 4000 units, the economic order quantity is dash. So here an item can be purchased 100 rupees and ordering cost is the 200 rupees, that is the C naught equal to the 200. Inventory carrying cost is 10% of the item cost per annum, which is equal to the 0.1 into 100, which is equal to the 10 per unit per year. So if the annual demand, which is capital D, equal to the 4000, then EOQ equal to the root of 2D C naught by CH. Substitute all the values, we will get the EOQ value is the 400. So option D is the correct answer. Let's see the next question. In inventory planning, extra inventory is unnecessarily carried to the end of the planning period when using one of the following lot size decision policies. Obviously, option B is the correct answer. Economic order quantity lot size. Next question is, one of the following statements about PRS, periodic reordering system, is not true. Identify. Option A. PRS requires continuous monitoring of inventory levels. Option B. PRS is useful in control of perishable items. Option C. PRS provides basis for adjustment to account for variations in demand. Option D. In PRS, inventory holding costs are higher than the fixed order quantity system. So option C is the correct answer. Let's see the next question. Setup cost do not include. Option A. Labor cost of setting up machines. Option B. Ordering cost of raw materials. Option C. Maintenance cost of the machines. Option D. Cost of processing the workpiece. So we know that one setup cost is the most incurred to prepare a machine or production system for a production run. So it is incurred each time production is started or changed over. So setup cost are including the labor cost of setting of machines, machine downtime during the setup, tool changes and adjustments, and the testing and calibration cost. So among this one, so labor cost of the setting of machines, so it is the included, and ordering cost of raw material, it is not included. Maintenance cost of the machine included, and the cost of processing the workpiece, it is also included. So only ordering cost of raw material is not included. Option B is the correct answer. Let's see the next question. If the demand for an item is doubled and the ordering cost is off, the economic order quantity, option A, remains unchanged. Option B increases by a factor of root 2. Option C is doubled. Option D is off. So let's see the solution. We know EOQ equal to the root of 2D C naught by CH. Here D will become the 2D and C naught equal to the 1 by 2 C naught. Then EOQ equal to the, so 2 into 2D into 1 by 2 into C naught divided by CH. So here 2 will get cancelled. Then EOQ equal to the root of 2D C naught by CH. So it is the remains unchanged. Option A is the correct answer. Let's see the next question. A food processing company uses 25,000 kg of corn flour every year. The quantity discount price of corn flour is provided in the table below. So here it is given the different unit price for the different quantity. And here observe there is the two price breaks. One is at the 750, another one is at the 1500. The order processing charges are 500 rupees per order. The handling plus carry over charge on an annual basis is 20% of the purchase price of the corn flour per kg. Then the optimal order quantity is dash. So let's see the solution. So here given the annual demand, capital D equal to the 25,000 kg, and B1 price break, B1 equal to the 750 and the second one is the 1500. and ordering cost is the 500 is given, and handling plus carry over charges on annual basis is 20% of the purchase price of the corn flour per kg. So small r equal to the 0.2. First we determine the EOQ at the lowest cost. Here lowest cost is the 60 rupees. So at the 60 rupees, EOQ value is the 1443.37. So at the 60 rupees unit price, required quantity is 1500 and above. So this quantity is not feasible. So next we have to go for the, okay, next we have to calculate the Q2 star based on the price C2. So here C2 value is the 65 and Q2 star value is the 1386.75, which is lies between the 750 to 1499. So this quantity at the unit price is feasible. Then we have to compare the total cost of the Q2 star quantity as well as the B2 quantity. So first we have to determine the total cost at the Q2 star quantity. So for the Q2 star quantity, unit price is the 65 rupees. Then total cost will become the 16,43,027.75. Similarly, you have to calculate the total cost for the B2 quantity. So at the B2 quantity is the 1500. At the B2 quantity unit price is the 60 rupees. Then total cost will become the 15,17,333.33. So among these two, so lowest cost is the, so price at the 60 rupees for the quantity of 1500. So optimal order quantity is the 1500. Let's see the next question. The annual demand for an item is 10,000 units. So given data is annual demand for an item is 10,000. So capital D equal to the 10,000 units. The unit cost is 100 rupees. So C equal to the 100 and inventory carrying charges are 14.4% of the unit cost per annum. So which is equal to the smaller, which is equal to the 14.4% which is equal to the 0.144. And the cost of one procurement is 2000 rupees, which is the ordering cost C naught equal to the 2000. Then we have to determine the time between two consecutive orders to meet the above demand. So which is the T star. So we know that when the T star equal to the Q star divided by D. So first we have to determine the Q star. So which is equal to the, so 1666.66. Then T star equal to the, so 0.16 year, but we need in the months. Then 0.16 into 12, which is equal to the 2 months. Let's see the next question. Annual requirements of rivets at a ship manufacturing company is 2000 kg. The rivets are supplied in units of 1 kg, costing 25 rupees each. If it costs 100 rupees to place an order and the annual cost of carrying 1 unit is 9% of its purchase cost, then the cycle length of the order will be dash. So here given the annual requirement of rivets, capital D equal to the 2000, and given the rivets are supplied in units of 1 kg costing 25 rupees. So unit price per the 1 kg equal to the 25, then C equal to the 25. And if it is cost is 100 rupees to place an order, so ordering cost is the 100. Annual cost of carrying 1 unit is 9% of its purchasing cost. So let's consider small r equal to the 0.09. Then we have to determine the cycle length of the order will be dash. So T star we have to determine. We know T star equal to the Q star divided by Q. Then Q star equal to the 421.637. Then T star equal to the 76.98. Let's see the next question. A manufacturer can produce 12,000 bearings per day. The manufacturer received an order of 8,000 bearings per day from a customer. The cost of holding a bearing in stock is rupees 0.2 per month. Setup cost per production run is 500 rupees. Assuming 300 days in a year, then the frequency of production run should be option A 4.5 days, option B 4.5 months, option C 6.8 days, option D 6.8 months. So let's see the solution. Here is given the data is production rate 12,000 bearings per day. Then year wise, per year it is having the only 300 working days. Then production rate per the year 36 lakhs. Similarly, consumption rate is given per day, it is the 8,000. So 8,000 into 300. So it is the 24 lakhs. So let's consider consumption rate equal to the small d, which is the 24 lakhs. And given the cost of holding a bearing is the 0.2 per month. It is given the month wise 0.2 per month. So year wise mean 0.2 into 12, which is equal to the 2.4. And setup cost per production run is 500 rupees. So which is the C naught equal to the 500. Then we have to determine the frequency of production run, which is equal to the EOQ divided by consumption rate, small d. Okay, so this model is model 1C because production rate is given. Then we know Q star equal to the root of 2D C naught by CH into P divided by P minus D. Substitute all the values. Then we will get the Q star equal to the 54,772. So next we have to determine the frequency of production run, which is equal to the Q star or EOQ divided by small d. So here Q star value is the 54,772 and small d value is the 24 lakhs. Then frequency of production run equal to the 0.228 year. So this is we have to convert into the days wise. Here we have to consider only 300 days. Then 0.228 into 300, which is equal to the 6.84 days. So option C is the correct answer. Let's see the next question. Consider the following data with reference to elementary deterministic economic order quantity model. So here it is given the annual demand, capital D is given the 1 lakh, unit price of the item C equal to the 10 rupees, and inventory carrying cost per unit per year CH equal to the 1.5, and ordering cost, unit order cost C naught equal to the 30. Then we have to determine the total number of economic order per year, which is equal to the capital D divided by EOQ. So here we have to substitute. So D equal to the 10,000 and EOQ value we have to determine, which is equal to the root of 2D C naught by CH, which is equal to the 2000. Then total number of economic orders per year equal to the 50 orders. Let's see the next question. A company uses 2555 units of an item annually. Delivery lead time is 8 days. Then the reorder point to achieve optimum inventory is option A 7, option B 8, option C 56, option D 60. So we know that when the reorder level equal to the lead time into small d, where small d is the daily consumption rate. Then reorder level equal to the lead time 8 into small d equal to the, so 2555 divided by 365, which is equal to the 56 days. So then option C is the correct answer. So let's see the next question. The maximum level of inventory of an item is 100 and it is achieved with infinite replacement rate. The inventory becomes 0 over 1.5 months due to consumption at a uniform rate. This cycle continues throughout the year. The ordering cost is 100 rupees per order and inventory carrying cost is 10 rupees per item per month. The annual cost of the plan neglecting material cost. Option A 800, option B 2800, option C 4800, option D 6,800. So let's see the solution. Here given the maximum inventory level, which is the Q equal to the 100 units. And next to replenishment rate equal to the infinite, and the cycle time, it is given the cycle time equal to the 1.5 month. So then T star equal to the 1.5 month. And ordering cost C naught is given 100 rupees. And the carrying cost is given the CH equal to the 10 rupees per item per month. Then have to determine the total annual cost. So total annual cost, but neglecting the material cost. Purchasing cost we have to neglect. Then total cost equal to ordering cost plus carrying cost. So total cost equal to the ordering cost plus carrying cost. We know ordering cost equal to the number of orders into ordering cost per order. Then total cost equal to the number of orders, which is equal to the 1 divided by cycle time. Here cycle time is given the 1.5 per month. Then number of orders equal to the 1 divided by 1.5. But we need the orders per month. So we need the year wise into 12. So number of orders equal to the 1 by 1.5 into 12. And ordering cost per order is the 100. So total cost equal to the ordering cost will become the 1 divided by 1.5 into 12 into 100. Average inventory carrying cost. Average inventory carrying cost equal to the 1 by 2 into Q into the CH. So 1 by 2 into, so Q value, maximum inventory level equal to the 100. And carrying cost 10 rupees per month, but actually we require the annually, so 10 into 12. Then total cost equal to the 6,800. Let's see the next question. In a machine shop, pins of 15 mm diameter are produced at a rate of 1000 per month, and the same are consumed at a rate of 500 per month. The production and consumption continue simultaneously till the maximum inventory is reached. Then inventory is allowed to reduce to 0 due to consumption. The lot size of production is 1000. If backlog is not allowed, the maximum inventory level is option A 400, option B 500, option C 600, option D 700. So let's see the solution. So production rate is given. So 1000 per month, and consumption rate is given small d equal to the 500 per month, and lot size of the production, which is equal to 1000, which is nothing but inventory lot size. So which is the Q equal to the 1000, and the maximum inventory level, let's consider the I max, we have to consider. So this model is belongs to the model 1C, economic production quantity here. So maximum inventory level I max equal to the TP into P minus D. TP is the time for the production. So time of production TP equal to the production size divided by production rate, which is equal to the 1. Then I max, which is equal to the 1 into 1000 minus 500. So answer is the 500, and thank you.